Okay, welcome to temptalks.com, and I've been discussing a lot of information about organic chemistry, and we're still proceeding. But right now, we want to look at homologous series. Homologous series. Now, homologous series are simply compounds or groups of compounds with the same functional group. Yeah. Groups of compounds with the same functional group. Groups could be many, compounds could be different. Take an example, have different molecular weight, different number of carbon atoms, everything different. But for as long as they have the same functional group, then they qualify to be under the same homologous series. Now, these compounds which have the same functional group are called homologies. Homologies. Yes. These compounds which are a homologous series or groups of compounds with the same functional group fall under homologous series. And these ones with the same functional group, we refer to them as homologies. Yeah, so when I say homologies, then I'm meaning homologous series, or I'm meaning groups of compounds with the same functional group. Now, that takes us to characteristics. Of homologous series. Characteristics of homologous series. Now, I think it is quite easy to understand that if they are homologous series, then they must have the same functional group. You can't be a homologous series with different functional groups here. Take an example, if you are alkanes, all of you should be alkanes. If you are men, all of you should be men, because men have the same functional group. We cannot categorize men with women, because they too have different functional groups. Now, these homologous series have got same, or somebody can say similar, chemical properties. They have same or similar chemical properties. Of course, similarity in the chemical properties is because of the functional group. Once compounds have the same functional group, then it should behave the same. That is why all men will put on trousers, because they have the same functional group. That is why all of them will behave the same, really. They would easily flock together. Just like we say, birds of the same feathers flock together. Even the homologies also flock together by having similar chemical properties, by having the same functional group. Then, homologies differ from one member to the next by a methylene group. They differ from one member to another by the methylene group. Now, let us first look at what a methylene group means. I can do that using this C3. This group is what we call a methylene group. That's a methylene group. Take an example, that is an alkane with 3 carbon atoms. What is the difference between an alkane with 3 carbon atoms and an alkane with 4 carbon atoms? Yeah, that's the difference. This one will have 1 methylene group, while this one will have 2 methylene groups. So both of these two lie under alkanes. But this one has 2 methylene groups, this one has 1 methylene group. And that's why we are saying that really homologies will differ from one to the next by the difference, or the difference in the number of the methylene group. Difference methylene group. Then next, homologies have different physical. Yeah, remember we said the chemical properties are the same, but the physical properties are different. They have different physical properties. And these differ due to the difference. They differ due to the difference in molecular mass. Yeah, we are saying that homologies have the same, have different physical properties. And what causes the difference is basically the difference in their molecular mass. Now, let me look at a few examples of their physical properties. One of the physical properties of the homologous series is solubility. Solubility is a physical property. Now I want to compare the solubility of this alcohol and this alcohol. We know quite well that all alcohols are supposed to be soluble, but solubility depends on the molecular mass of the respective compounds. When you consider the mass of this one, it's too small compared to the mass of the other one. Now, what causes the solubility is the polarity of the functional group. This functional group is polar, and this functional group is also polar because they're the same. But this functional group is surrounded by a lot of carbon, high carbon content. So we can say this one has got high carbon content. Carbon content. Now, the higher the carbon content, the higher the covalence. Remember, for the two compounds to be soluble, they should be able to dissolve in water. And water is a polar solvent. Water is a polar solvent. Now, as the carbon content increases, there is increase in covalence. But remember, water is a polar compound, polar solvent, which does not dissolve covalent compounds. So the increase in the covalence causes a decrease in the solubility, as far as water is concerned. But this one, being a very small compound, has got a low degree of covalence compared to the covalence which is here. In other words, covalence outcompetes the polarity. The compound is supposed to be polar because it has a polar functional group, but because of the high carbon content, which increases considerably on the magnitude of covalence, then the covalence is able to outcompete the polarity. The molecule ends up being almost insoluble, yet it would have been soluble. The difference between the two alcohols is that this one has a very high molecular mass and this one has got a very low molecular mass. That is the effect of molecular mass on solubility, which is a physical property. Right.